Hello everyone, this is Chinnaiah Kalpana here. In this video, we are going to solve a differential equation from higher order linear differential equation. So let's get going. Problem. Solve d square plus 4 into y equals to x power 4 plus cos square x. So firstly, let's find the order and degree of the given differential equation. Identify the highest derivative here. D square is the highest derivative, so our order will be 2. And the highest power of the highest derivative is that degree. Degree is 1. Or just write the given differential equation as d squared y plus 4y equals to x power 4 plus cos square x. Right? We know that d is a differential operator. Then d square will be d square by dx square. Now we can write d square y as d square y by dx square plus second term and RHS will be as it is. Here d square y by dx square is the highest derivative, so our order will be 2, and the highest power of the highest derivative is a degree. Degree is 1. Okay, highest power of a highest power of a highest derivative is a degree. Degree is 1. Now coming to the problem. Given differential equation, d square plus 4 into y equals to x power 4 plus cos square x, which is in operator form. F of d into y equals to q, where f of d is d square plus 4 and q is x power 4 plus cos square x. Right? So now we need to find the general solution to the given equation, which is given by y equals to yc plus yp. Here yc is a complementary function and yp is a particular integral. We'll find yc using the roots of our auxiliary equation of the homogeneous equation of the given non-homogeneous equation. Simply by putting RHS to 0, we'll get the homogeneous equation f of d into y equals to 0 of our given non-homogeneous equation. Okay, and we'll find yp using 1 by f of d into q. So firstly, let's find yc complementary function using the auxiliary equation. The auxiliary equation of homogeneous equation is f of m equals to 0, where f of m equals to, we have f of d squared plus 4. Let's replace differential operator by m, so that we'll get f of m equals to m square plus 4. Now our auxiliary equation becomes m square plus 4 equals to 0. Right? Now let's find roots. M equals to plus or minus square root of minus 4. Now let's write minus 4 as minus 1 into 4 and split square root of minus 1 into 4 as square root of minus 1 into square root of 4. We know that square root of minus 1 is I and square root of 4 is 2. Right? This becomes plus or minus I into 2 or plus or minus 2I. Right? So we got imaginary roots. Therefore, m equals to plus or minus 2I are the roots of our auxiliary equation, right? Which is a pair of purely imaginary roots. Why we are calling it as purely imaginary? Because we don't have any real part, right? Fine. We know that a plus ib is a complex number and its conjugate is a minus ib. If a minus ib is a complex number, its conjugate will be a plus ib, right? So we can call it a plus or minus ib as complex conjugates, right? If we have complex conjugates, then yc will be, if we have roots which are complex conjugates, then yc will be e power ax into c1 cos bx plus c2 sin bx. In case of a0, you will get 0 into x, which is e power 0 into c1 cos bx plus c2 sin bx, right? Since we know that e power 0 is 1, then we'll get 1 into c1 cos bx plus c2 sin bx, right? Finally, our yc will be 1 into c1 cos bx plus c2 sin bx is c2 cos bx, c1 cos bx plus c2 sin bx, right? Now, for m equals to plus or minus 2i, our complementary solution looks like yc equals to c1 cos 2x plus c2 sin 2x, right? Now let's find yp, particular integral. We know that we can find yp using 1 by f of d into q. We have f of d, d square plus 4, and q is x power 4 plus cos square x, right? We know that cos 2 theta equals to 2 cos square theta minus 1, right? Or we can just write it as 2 cos square theta minus 1 equals to cos 2 theta for our convenience, because we are going to find cos square theta formula, okay, an identity. Otherwise, so now take this to 2 RHS. No, firstly take this minus 1 to RHS, then you'll get 2 cos square theta equals to cos 2 theta plus 1, right? Now take this 2 to RHS, we'll get cos square theta equals to 1 by 2 into cos 2 theta plus 1, or 1 by 2 into 1 plus cos 2 theta, right? Now we can just replace theta by x, then we'll get cos square x equals to 1 by 2 into 1 plus cos 2x, right? Now replace cos square x by this identity. This becomes 1 by d square plus 4 into x power 4 plus 1 by 2 into 1 plus cos 2x, which is equals to 1 by f of d into x power 4 plus 1 by 2 into 1 by f of d into 1 plus 1 by f of d into cos 2x. Now let's find 1 by f of d into x square, 1 by f of d into 1, and 1 by f of d into cos 2x separately. Okay, firstly I am going to find 1 by f of d into x power 4, the first term. Okay, and this is of 1 by f of d into some x power k or x power n form, right? 1 by f of d into x power 4 is of 1 by f of d into x power n form. So now what we'll do, firstly let's find derivatives of x power 4. For our convenience, we are going to find derivatives of x power 4 before going to 1 by 14 into x power 4. Okay. Derivative of x power 4 is 4 into x cube, and d square of x power 4 is 4 3s are 12 into x square, and d cube of x power 4 is 12 2s 24 into x, and d power 4 of x power 4 is 24. Right? Derivative of x with respect to, see, I'll show you in detail explanation. We can write d power 4 of x power 4 as d into d cube of x power 4. Since we have the value of d cube of x power 4, now place the value of d cube of x power 4 here, is equals to 24 into derivative of x. We know that derivative of x is 1. So finally, d power 4 of x power 4 is 24. Right? Now we can find d power 5 x power 4. This is equals to d power 5 of, derivative of d power 4 of x power 4. We have the value of d power 4 of x power 4, which is 24. And we know that the derivative of constant with respect to x is 0. Right? So d power 5 of x power 4 is 0. From here, you will get all the higher derivatives 0. All the higher derivatives of x power 4 is 0. In general, if we just name x power 4 as some r, say r, then d power k of r is 0 for k equals to 5, 6 and so on. Right? In general, d power k of r is 0 for k equals to 5, 6 and so on. So we'll get the values of x power 4 till 4. Right? We'll get only derivatives till d power 4. Here we have named x power 4 as r. Fine. Now, coming to the problem. Now let's write the denominator in ascending form. Okay. Now we need to take the lowest degree term common from all the terms in the denominator. We'll just take 4 common from these two terms. Okay. But in the second term we don't have any 4. So what we'll do? We'll just multiply and divide a 4 to this term, so that in the next step it will be easy to take 4 common from the two terms. Right? So we'll get 1 by 4 into 1 plus 1 by 4 into d square into x power 4. Right? Is equals to, now we can write the fraction as 1 by 4 into 1 plus d square by 4 into x power 4. Now split the fraction into two fractions. 1 by 4 into 1 by 1 plus d square by 4 into x power 4. Right? See, the second fraction is of 1 by 1 plus x form. So we can write it as 1 plus x whole inverse. Okay? And finally, we'll use binomial series expansion. Okay? So this equals to 1 by 4 into, write 1 by 1 plus x as 1 plus x whole inverse into x power 4. Now let's see how to expand this by keeping all these 4 derivatives in mind. Okay? You just need to keep d power 4 in mind. We have 1 plus x whole inverse equals to 1 minus x plus x square minus x cube plus x power 4 minus x power 5 and so on. Right? So, for x equals to d square by 4, we can expand 1 plus d square by 4 whole inverse as 1 minus d square by 4 plus d square by 4 whole square. See, now here you have to notice that x square. For this x square we got d square by 4 whole square, and d square whole square is d power 4, right? A power m whole power n, right? D power 4. And the next step, in the next term you'll get d square by 4 whole cube. D square whole cube is d square into 3, which is d power 6, right? But we have derivatives value still d power 4. From here after you'll get zeros, right? Which means that you can neglect term d power 4, or you can neglect terms from minus x cube, because we are getting higher derivatives from here, right? Is equals to 1 minus d square by 4 plus d square whole square is d power 4 by 4 square is 16 minus d square whole cube is d power 6 by 4 cube. 4 4s are 16, 16 4 64, plus so on, right? So we can neglect higher derivatives from here, right? From after the first 3 terms. Now we can expand 1 plus x whole inverse as 1 minus d square by 4 plus d square by 4 whole square minus d square by 4 whole cube plus d square by 4 whole power 4 minus and plus so on, right? I'll stop it here. Plus so on into x power 4, which is equals to 1 by 4 into 1 minus d square by 4 plus d square whole square d power 4 by 4 square 60 minus d square whole cube is d power 6 by 4 cube is 64 plus so on into x power 4. Right? For r equals to x power 4, derivative or d power k of r is 0 for k equals to 5, 6 and so on. So neglect higher derivatives from d power 5, d power 6 and so on, right? So we can neglect terms from here. So this becomes 1 by 4 into 1 minus d square by 4 plus d power 4 by 16 into x power 4. This is 16, right? Yeah. Now this becomes 1 by 4 into 1 minus 1 by 4 into d square plus 1 by 16 into d power 4 into x power 4, which is equals to 1 by 4 into 1 into x power 4 is x power 4 minus 1 by 4 into d square of x power 4 plus 1 by 16 into d power 4 of x power 4, right, is equals to 1 by 4 into x power 4 minus 1 by 4 into, we have the value of d square of x power 4, which is 12x square plus 1 by 16 into, again, d power 4 of x power 4 value is 24, right? this becomes 1 by 4 into x power 4. 4 ones are 4 threes are 12, right? 4 fours are 16, 4 six are 24, 2 twos are 2 threes are. So you'll get x power 4 minus 3 x square plus 3 by 2. Therefore, 1 by f of d into x power 4 is 1 by 4 into x power 4 minus 3x square plus 3 by 2. Now let's find 1 by f of d into 1. So here we are having 1 by f of d into constant, right? So we can write this constant as e power some 0 into x, since e power 0 into x is e power 0, which is equals to 1, right? So we'll replace 1 by e power 0 x. So that we'll get 1 by d square plus 4 into e power 0 x, which is of 1 by f of d into e power ax form, right? For a equals to 0. Just compare e power 0x with e power ax, and for a equals to 0. We have f of d, which is equals to d square plus 4. Now let's find f of a, which is f of 0, is equals to, just replace d by 0, we'll get 0 plus 4, or 0 square plus 4, which is 0 plus 4, which is 4, not equals to 0. Always remember that the denominator must be non-zero. If we get the denominator 0, we'll get something like this. 1 by 0 into e power 0x. We know that 1 by 0 is undefined, so the total term becomes undefined. Right? Now, by replacing d by 0, we got 4, which is non-zero, since f of 0 is not equals to 0. So, we can replace this d by 0. We'll get 0 plus 4 into e power 0x, which is equals to 1 by 4 into e power 0x, which is equals to 1 by 4 into e power 0x is e power 0, which is equals to 1 by 4 into 1, which is equals to 1 by 4. Therefore, 1 by f of d into 1 is 1 by 4. Now let's find 1 by f of d into cos 2x. So this is of 1 by f of d into some cos ax form, right? For a equals to 2. Now let's find d square, which is given by formula minus a square, is equals to minus, for a equals to 2, you'll get minus 2 square is 4, right? Now let's see what happens if we replace d square by minus 4 in the denominator. Okay, always the denominator must be non-zero. See what happens if we replace d square by minus 4. We'll get 1 by minus 4 plus 4 is 0 into cos 2x. Since 1 by 0 is undefined, so the total term becomes undefined. So what we have to do here? We'll just write x into 1 by, find the derivative of f of d. If f of d equals to d square plus 4, then f dash of d is 2d plus derivative of a constant is 0, which is 2d, right? Here we need to write 2d into cos 2x is equals to x into, we can split 1 by 2d as 1 by 2 into 1 by d into cos 2x is equals to x into 1 by 2 is x by 2 into, find, here 1 by d is an integral operator, so we need to find integration of cos 2x. We'll get sine 2x by 2. Okay, or you may include one more step here for your convenience. integral cos 2x dx, right? Which is equals to x by 2 into integral cos 2x dx is sine 2x by 2, which is equals to x sine 2x by 2 2s are 4. Therefore, 1 by f of d into cos 2x is x sine 2x by 4. So we got the values of 1, 2 and 3. Okay, let's name it as 1, 2 and 3. And now we can write yp. Now coming to yp, result obtained from 1 by f of d into x power 4 is 1 by 4 into x power 4 minus 3x square plus 3 by 2 plus 1 by 2 into result obtained from 1 by f of d into 1 is 1 by 4 plus result obtained from 1 by f of d into cos 2x is x sine 2x by 4. These are required yp. Now we can write the general solution. We know that the general solution is given by y equals to yc plus yp, right? Then our general solution will be y equals to yc. We have c1 cos 2x plus c2 sin 2x, and yp is 1 by 4 into x power 4 minus 3x square plus 3 by 2 plus 1 by 2 into 1 by 4 plus x sine 2x by 4. This completes the problem. So we have seen a problem from higher order linear differential equations in this video. Hope you'll understand. We'll see you in the next video. Until then, bye bye.